Welcome to the Module 6 of the Python programming course, Practical Step-by-Step Guide in Using Python. In this module, we move beyond theory and into hands-on practice, building 4 real working programs that draw on everything learned in the previous modules. This module covers 6 key areas. We will build 4 projects: a command line calculator, a student grade management system, a file-based contact book, and a number guessing game. We will also cover debugging and testing practicals and conclude with unit testing using Python's built-in unit test framework. Introduction: Understanding Python syntax, data types, control flow, and object-oriented features is necessary, but not sufficient for becoming a capable Python programmer. True proficiency is developed through practice by building real programs, working with actual data, and solving genuine problems. This module bridges the gap between theoretical knowledge and practical application. Each project begins with a clear problem statement, followed by a step-by-step walkthrough of the solution, with detailed explanation at every stage. This iterative approach mirrors the real-world software development process. The key message of this module is simple. You learn Python by writing Python. Every project here built a real working program using concepts from all previous modules. Project 1, Command Line Calculator. The first project is Command Line Calculator. The problem statement is as follows. Build a Python program that accepts 2 numbers and an operator performs the calculations that handles divisions by 0 and invalid input gracefully. The solution is structured into 4 steps. Step 1, define the 4 operation function: add, subtract, multiply, and divide. Note that the divide function includes a guard against division by 0. Step 2, maps each operator's symbol to its corresponding function using a dictionary. Step 3, define an input validation function using a try/except block to ensure the user enters a valid number. Step 4, implement the main calculator loop. Step 1, define operation function def add open parenthesis a, comma b, close parenthesis, colon, return a plus b. Def subtract open parenthesis a, comma b, close parenthesis, colon, return a minus b. Def multiply open parenthesis a, comma b, colon, return a times b. Def divide open parenthesis a, comma b, colon. If b is equal to 0, colon, return apostrophe error, colon, division by 0, apostrophe, return a/b. Step 2, map operators to function. Operation equals to curly brackets, apostrophe plus, close apostrophe, colon, add, comma, quotation mark, underscore, quotation mark, colon, subtract, comma, apostrophe, star, apostrophe, colon, multiply, comma, apostrophe, slash, backslash, apostrophe, colon, divide, then close the curly bracket. Step 3, input validation. Def gets underscore number, open parenthesis, prompt, close parenthesis, colon. While true, colon, try, colon, return, floats, open bracket, input, open parenthesis, prompt, close parenthesis, close the parenthesis, accept value error, colon, print, open parenthesis, apostrophe, enter a valid number, full stop, apostrophe, close parenthesis. Step 4, main calculator loop, def main, colon, print, open parenthesis, apostrophe, equals to, apostrophe, times 35, close parenthesis, print, Python command line calculator. So these are the examples of the project 1, which is command line calculator. Project 2, Student Grade Management System. The second project is Student Grade Management System. The program manages student names and scores with the following features: adding student record, displaying all records, calculating the class average, identifying the top student, and saving data to a JSON file. The code uses a dictionary as the primary data structure, where each key is a student name and the value is their score. The display function sort records in descending order of score using a lambda key. The save function uses the JSON model to persist data between sessions. A simple numbered menu drives the main program loop. So import JSON, def add underscore student records column. Name equals to input, open parenthesis, apostrophe, enter student name, column, apostrophe, close parenthesis, dot strip. Score equals to plot, input, enter, open parenthesis, enter, student score, column, close parenthesis, records, square bracket, name inside equals to score, print, open parenthesis, F, apostrophe, added, column, name inside curly bracket minus score equals to curly bracket, inside curly bracket score, apostrophe, close parenthesis. Def function now. To use the def function, def gets underscore grade score column. If score is greater than or equals to 90, return A. If score is greater than or equals to 75, return B. If score is greater than or equals to 60, return C. If score is greater than or equals to 50, return D. Else, column, return F. So this is the example of student grade management system. Project 3, that is file-based contact book. The third project is a file-based contact book. The program scores contact persistently in JSON file, meaning data is returned between program session. Features include adding, searching, display all, and deleting contacts, forming a full set of CRUD operation. The load underscore contact function check whether the JSON file already exists before attempting to read it. The search function uses a dictionary comprehension to find partial name matches. The delete function remove an entry and immediately save the updated contact back to the file. So the core function here is import JSON OS contact underscore file apostrophe contact dot JSON close the apostrophe dev loads underscore contacts if os dot pass dot exist open parenthesis contact underscore file column with open parenthesis contact underscore file R in between apostrophe as F colon return curly bracket dev save contact. So these are the four functions that have been described in this code. That is, the four functions are search, delete, main move. Each one is been described in the code. So if you follow it, you will understand everything. Project 4, that is number guessing game. The first project is number guessing game with difficulty levels, limited attempts, a scoring system, and a hint mechanism. The get underscore difficulty function return a tuple containing the lower bound, upper bound, and maximum number of attempts for each difficulty level, easy, medium, or hard. The play underscore game function generates a random secret number, then enters a loop where the player guesses until they are correct or run out of an attempt. Every 2 attempts, A hint is calculated based on attempt, use, and hint consumed. So this example describes the number guessing game. By following it step by step, you will also understand it. And if you run the program, you will see how it will be put in place and how it is being used. Debugging practicals, finding and fixing bugs. This slide presents a post-step debugging workflow used by professional developers. Step 1, read the error message. Python error message tell you exactly what went wrong, and on which line. Always read them fully before making any changes. Step 2, reproduce the bug. Identify the exact input or sequence of action that causes a problem. A bug you can reproduce consistently is a bug you can fix. Step 3, isolate the problem. Add strategic print statement around the suspected area of code to inspect variable values and compound where logic breaks down. Step 4, fix and verify. Make a targeted fix, then run the code with the same input. Test with edge cases such as empty input, zero and negative numbers. So below is the example of common debugging techniques, strategic print statements. Unit testing with unit test. Unit testing is the practice of writing automated tests to verify that individual functions work correctly. Python built-in unit test model provide a structured framework for this. Tests are written inside a class that inherit from unit test case. Each test method begins with the word test and uses assertion method to verify expected outcomes. Assert equally, check that two values are equal. Assert true, check that an expression is true. Assert raises, verify that a specific exception is raised under given condition. In the example below, we test four functions: add, multiply, get underscore, grade, and divide. Running the test file produces a clear report showing which test passed and which one failed. So by following this demonstrated example, you can quickly understand how you can perform unit tests using Python. The Python development workflow. This slide outlines 6-step workflow followed by professional Python developers. Step 1 is to understand the problem. Read the requirement carefully, identify inputs, expected output, edge cases, and constraints before writing any code. Step 2 is to plan the solution. Sketch the program structure, identify the function needed, and write pseudo code to map out the logic. Step 3 is to write the code, implement one function at a time, and test each as you go. Do not write the entire program before testing. Step 4 is to test and debug. Test with normal inputs, edge cases, and invalid input. Fix bugs systematically using debugging workflow. Step 5 is to refactor and clean. Apply PEP-X convention, the dry principle, meaningful names, and doctrine to make the code readable. Step 6 is to document and deploy. Write a README file. Document function with doctrine, list dependencies in a requirement.txt file, and use Git for version control. Code documentation standard. Professional Python code must be properly documented. This slide covers 3 levels of documentation: model doctrine, function doctrine, and inline comments. A model doctrine appears at top of a .py file and states its purpose, author, and version. A function doctrine describes what the function does, its arguments, its return value, and any exception it may raise. For inline comments, always explain the why, not the what. A comment that simply restates what the code does adds no value. A good comment explains the reason behind a decision or clarify complex logic. A README file should include a project description, installation instruction, usage example, a list of features, and author's name. So below are the coding example of how you can do code documentation by using the standard. It's a practical step-by-step guide in using Python. Do's and don'ts. Practical Python development. This slide summarizes best practices and common pitfalls in practical Python development. You should plan your program before writing any code. Build and test one function at a time. Always validate user input using try/except. Write unit tests alongside production code. Use meaningful names. Document all functions. Save work regularly with git commits. Test with edge cases and refactor after the code works. Avoid. Try to write the entire program at once, skipping testing, assuming user input will always be valid, leaving debug print statement in final code, copying code without understanding it, ignoring error message, committing untested code, writing function longer than 20 to 30 lines, and mixing input-output logic with business logic in a single function. Project summary. Let us review the key Python skill practice in each of the 4 projects. Project 1. The calculator covered function and dictionary input validation with try/except, while loops with menus, and the operator mapping pattern. Project 2. The grade system. Introduce the use of dictionary as a database, sorting with a lambda key, F-string formatting, and JSON file persistence. Project 3, the contact book, implemented persistent JSON storage, the os.path.exist, check, dictionary comprehension for searching and full CRUD operation. Project 4, the guessing game, apply the random model, nested loop, and break logic, score calculation, and a hint system using the model's operator. Conclusion. This model has provided a structured, hands-on guide to practical Python programming through 4 progressively complex projects. The command line calculator introduced function mapping and input validation. The student grade system demonstrated data-driven development with file persistence. The contact book introduced full CRUD operation with JSON storage, and the number guessing game added game logic with scoring and hints. The debugging workflow and unit testing section have established professional habits that learners will apply throughout their careers. The documentation standard covered in this model reinforce that code is written for humans as much as for machines. Key takeaways. Every line of code you write is practice. The more program you build, the more confident and capable you become as a Python programmer.